Pharmacological activation of autophagy is emerging as a compelling strategy in the treatment of obesity and its associated metabolic disorders. While lifestyle interventions like fasting and exercise remain foundational, certain compounds that stimulate autophagy at the molecular level offer new potential for individuals who struggle with weight loss or face severe metabolic dysfunction. Drugs such as rapamycin, spermidine, metformin, and newer experimental agents are gaining attention for their ability to enhance autophagic flux, the rate at which cells break down and recycle damaged components, especially in tissues most impacted by obesity, such as liver, fat, muscle, and even the brain. Rapamycin, originally developed as an immunosuppressant, is a well-known inhibitor of the mTOR pathway, a nutrient-sensing system that normally suppresses autophagy when food is abundant. By inhibiting mTOR, rapamycin lifts this block and reactivates autophagy, allowing cells to enter a state of internal repair and renewal. In animal models, rapamycin has shown the ability to reduce fat mass, improve insulin sensitivity, and protect against age-related metabolic decline. However, long-term use is not without risks. Its immune-suppressing properties, as well as potential effects on glucose tolerance, make it unsuitable for general population use without close monitoring. Still, its success has inspired the development of newer compounds that mimic its beneficial effects on autophagy without the broader systemic downsides. Spermidine, a naturally occurring polyamine found in foods like wheat germ, soybeans, and aged cheese, represents a more accessible and potentially safer option. It promotes autophagy by enhancing the acetylation of key proteins involved in cellular turnover, and in studies, it has been shown to reduce fat accumulation, improve cardiovascular health, and increase lifespan in model organisms. Unlike rapamycin, spermidine has a nutritional origin and a more favorable safety profile, making it a promising candidate for long-term metabolic support. In the context of obesity, spermidine supplementation may help improve mitochondrial function, reduce inflammation, and promote fat mobilization, all through the lens of enhanced autophagy. Other drugs like metformin, widely used in type 2 diabetes, also induce autophagy through YMPK activation and inhibition of mitochondrial complex I. Metformin's ability to lower blood glucose and improve insulin sensitivity may, in part, be attributed to its subtle enhancement of autophagic pathways, especially in the liver. Although it is not prescribed solely for obesity, its indirect effects on body weight and fat distribution make it a valuable therapeutic tool. Newer research is also exploring compounds such as resveratrol, NAD+ precursors like NMN and NR, and calorie restriction mimetics, all of which aim to stimulate cellular cleanup processes and restore metabolic balance. The appeal of pharmacological autophagy activators lies in their potential to target the root cellular dysfunctions of obesity, rather than merely suppress appetite or block nutrient absorption. By re-engaging the body's natural repair systems, these compounds offer a way to improve fat utilization, reduce ectopic lipid accumulation, and enhance insulin responsiveness. They also show promise in addressing obesity-related comorbidities such as fatty liver disease, cardiovascular dysfunction, and even cognitive decline, all of which involve disrupted autophagy as part of their pathology. Yet despite the excitement, caution is warranted. Artificially stimulating autophagy can have unpredictable effects depending on timing, dosage, and the individual's underlying health status. Overactivation in the wrong context may impair tissue function, promote muscle wasting, or interfere with immune defense. Moreover, many of the most potent autophagy-inducing compounds are still in early-stage clinical trials or animal studies, and more human data is needed to understand long-term safety and efficacy. That said, the future is promising. As we better understand the cellular and genetic mechanisms underlying obesity, the potential to fine-tune autophagy pharmacologically becomes more realistic. With the right dosing strategies and patient selection, these drugs may complement behavioral interventions, making weight management more achievable and sustainable, especially for those whose biology resists conventional approaches. This shift from surface-level symptom control to deep cellular repair reflects a growing paradigm in medicine, treating the cause, not just the consequence. Supporting autophagy pharmacologically may become one of the most powerful ways to reset the body's energy systems and give people a stronger foundation for lifelong metabolic health.